Up next, we got 1.4, estimating limit values from tables. So we learned how to do it from a graph. You look at the graph, you look at the line, and you see where it's at. So if we have this graph here, we can see that there's a hole at 2, 4, but we know that the limit of f of x when x is approaching 2 is 4. Because you look at it, 2, okay, where's it going? Oh, okay, it's going 4, right? From left side, from the right side, they all agree it's 4, right? But what would we do if we had a table of this graph, but we weren't actually able to see it? This is a table of this graph. 2, there is no value at 2. If we put 2 in this table, it does not exist. But 2 would go like right here in between 1.99 and 2.01. And if you look from the left side here, you have 1.9 to 1.99. That's going to be the line coming up this way. It's going to be like right up close to 2, right? 3.8, 3.98 is getting really close to 4. And from the right side, 2.01 is just over 4. So if you have just under 4 on this side and just over 4 on this side, you could assume that if you have 2, it's going to be 4. And then that's basically what this concept is. You just look at the table. You look at, oh, okay. As it from the left side, it's approaching 4. From the right side, it's approaching 4. So it looks like the limit is going to be 4, even if the point itself does not exist. I got a little practice problem up here. So if you wanted to find the limit when x is approaching -6 of f of x, and you just had this table, what would you do? So you see that when it's getting closer to 6 from the left side down here, because these are smaller numbers, or -6, it's getting really close to 3.5. It's not quite touching it. And then from the right side down here, it's getting close to 3.5 as well. And right in the middle right here would be -6. And you could assume it would be 3.5. So this table concept is pretty easy. You're just looking at the table and looking at the number that's in between and that is getting closer to on both sides. Last part of this section, what are you supposed to do if they don't give you a table? If they just give you an equation and you have to figure it out, the first way that they teach you is you could just make a table yourself. So for example, if they give you this equation right here, f of x equals x squared minus 9 over x minus 3, and they tell you to find the limit of f of x when x is approaching 3, what would you do? You could make a table of the x and y values that you have. You could, you want to take them, you want to get really close to 3 on both sides. So we'll put, in this table, we'll put 2.9, 2.99, 3, 3.01, and 3.1. Because if you plug 3 into this equation, you'll get 0 over 0, and you can't do that. So that's why you have to put all of these into the table to get close to it. So 3 does not exist. F of 3 does not exist, right? Because you can't plug 3 into this equation. So if you plug 2.9 in, 2.99, 3.01, and 3.1, you'll be able to see how it's approaching from both sides. To do this, you should use a calculator. You could use Desmos. You could use the TI-84 that your teachers want you to get. Yeah, so you can put it in now if you want. I'll give you a second. Okay, cool. So people that aren't going to put it in, I'll put it in for you. You got 5.9, 5.99, 6.01, and 6.1. And again, to find these, I just plugged this equation into a calculator and plugged all these numbers into the equation. So from the left side, 5.9, 5.99 is getting close to 6. And from the right side, 6.1, 6.01 is getting close to 6. So from this, you could just assume that the limit as x approaches 3 of this equation is 6. So you could just make it, if you don't know, you just make a table, put things in on the left side that are close to it, things on the right side, plug it all into a calculator, and you'll get your limit, you'll get your answer. It's that simple. This section is pretty simple. Okay, now in this situation, the numbers change a little bit, but we're gonna apply the same one-sided limit concept that we just learned and apply it to this. So if you look at this equation now, they're from the left and right side, they're approaching two different points, right? Because from the left, it's approaching 3.5 as before, and from the right, in this new equation, it's approaching 7. So this is the same thing. If you write limit when x is approaching -6 of f of x from the left side, right? You would look at these ones down here because they're from the left, and 3.2, 3.4, 9, 9, 9, 9. You could assume that it's approaching 3.5. if you look at this from the right side, limit f of x when x is approaching -6. From the right, 6.7, 6.9, you could assume that the next point would be 7. So from the right side, it would be 7. But then if you take this and you look at just the normal limit when x is approaching -6 of this new equation, since from the left is approaching 3.5 and from the right is approaching 7, it does not exist because they do not agree. The graph of this, there would be like a jump in it. Like from the left, it would be approaching 3.5 like this, and from the right, it would be approaching 7 like this, and this would be 7 up here, this would be 3.5 here, right? So since it's like this, the limit of -6 in this case does not exist because there's this gap here, and the left and right side are two different numbers.